This question, so we have the following Markov chain, and I also write it as a matrix. And now we want to know what is the stationary distribution for each of these initial states. So for the first initial state, we start at state 3. Okay, so this is state 0, this is state 1, this is state 2, 3, and 4. Anyway, so we want to know what is the stationary distribution for each of the states. So for state 3, so we need to think about it. This is a closed state because we cannot exit each one of the states, or 3 or 4. So we either in state 3 or 4, so we can look at it as a small matrix that we cannot escape from. So I just write it as this, like as the new matrix. And now we want to know for this small matrix what is the stationary distribution. So it's A comma B multiplied by this matrix equal A comma B. And now we just solve for that, we solve for that, and we also need to remember that the sum of A plus B is 1, because this is the total amount of probability. So now we get the stationary distribution will be 2/3, comma third. And now we ask for what is the stationary distribution of 1 and of the 0, meaning we start at state 0, meaning we cannot escape state 0, so the stationary distribution is just staying in state 0 forever. And now we ask the last question, which is, let's calculate what is the stationary distribution for starting at state 1. For this, we will need to look at two options. Either we go to state 0 and we stay there forever, or we go to state 3 or 4 and we stay there forever. So to do that, we will need to calculate as following. There is for h10, meaning the probability we will ever get to state 0 will be 1 divided by 4 multiplied by and I will just show you the formula. So h10 will be 1 divided by 4, which is the probability to go straight to state 0, plus 3 divided by 4 to go ever from state 2 to state 0. And now we do the same formula for state from 2 to state 0, which is either going from state 2, we have 1 divided by 3% chance to go from state 2 multiplied by the probability to go from state 1 to state 0, and go from state 2 to again to itself. So this is the two equations we get, and now we just solve the equation and we get h1 of 0, meaning the probability will start from 1 and we ever go to 0. And we know that if h1 of 0 is 2 divided by 5, so h of 1 to 3 will be 3 divided by 5. So we have 2 divided by 5% chance to go from state 1 to 0 ever, and 3 divided by 5 to go from state 1 to 3 ever. And now we just really easy, we take the proportion of the proportion of each of the stationary distribution into the vector. So 2 divided by 5 multiplied by this stationary distribution, and 3 divided by 5 divided by this stationary distribution. And now we have a really easy time. We just multiply 2 divided by 5 times 1, which is 2 divided by 5, and 3 divided by 5 by this vector is 2 divided by 5 and 1 divided by 5, which is the correct answer. Anyway, until next time, see you.